For millennia, humans have gazed at the stars, wondering what lies beyond our own galaxy. Among the countless celestial bodies in the universe, one galaxy stands out, our closest cosmic neighbor, the Andromeda Galaxy. Located 2.5 million light-years away, Andromeda is the largest and most massive galaxy in the local group, even larger than the Milky Way. It contains nearly 1 trillion stars, and its sheer size and beauty have fascinated astronomers for centuries. But beyond its mesmerizing spiral arms and dense star clusters, Andromeda holds a dark secret. Scientists have discovered that Andromeda is not just a distant celestial wonder. It is on a direct collision course with our galaxy. At an astonishing speed of 110 kilometers per second, 68 miles per second, it is slowly but inevitably approaching us. In the far future, this galactic behemoth will merge with the Milky Way, unleashing cosmic chaos on an unimaginable scale. What will happen when Andromeda and the Milky Way collide? Will Earth survive this cataclysmic event? Could our solar system be thrown into the abyss of intergalactic space? And what other mysteries and dangers does Andromeda hide within its massive structure? From deadly supermassive black holes to hidden star-killing phenomena, the Andromeda Galaxy is far from being just a beautiful cosmic neighbor. It is a potential bringer of destruction. In this documentary, we will unravel the secrets of Andromeda, uncover its catastrophic fate, and explore what this impending galactic collision means for the future of our universe. This is the story of the greatest cosmic catastrophe yet to come. Welcome to the mystery of Andromeda. Keycap 1: Ancient Observations. The first records of Andromeda. The Andromeda Galaxy is one of the few galaxies visible to the naked eye. Ancient astronomers from China, Persia, and the Islamic world documented a small, cloud-like object in the constellation Andromeda. The earliest known mention dates back to 964 AD, when Persian astronomer Abd al-Rahman al-Sufi described it in his book of Fixed Stars as a little cloud. In 1612, German astronomer Simon Marius observed it through a telescope, describing its fuzzy, nebula-like appearance. For centuries, astronomers believed Andromeda was simply a nebula, a cloud of gas within the Milky Way. The idea that it was an entirely separate galaxy was almost unimaginable. Keycap 2: The Great Debate. Is Andromeda a galaxy or just a nebula? As telescopes improved, scientists began to notice something strange about Andromeda. Unlike other nebulae, it contained individual stars. But was it a distant cloud within our own galaxy, or something much bigger? In 1912, American astronomer Vesto Slipher used spectroscopy to measure Andromeda's motion. His shocking discovery? Andromeda was moving toward us at incredible speeds. In 1924, Edwin Hubble observed variable stars, Cepheids, in Andromeda and calculated its distance, 2.5 million light-years away. This proved a revolutionary idea. Andromeda was not a nebula. It was an entirely separate galaxy, similar to the Milky Way, but even larger. The universe was not just one galaxy. It was billions of them. Keycap 3: Modern Discoveries. Andromeda's Dark Secrets. Today, the Andromeda Galaxy is one of the most studied objects in astronomy. But along with its breathtaking beauty, it hides some terrifying secrets. A supermassive black hole at its center, much larger than the one in the Milky Way. Strange, high-velocity stars moving at speeds that suggest massive past collisions. A history of devouring smaller galaxies, consuming them in its vast gravitational pull. Keycap for the shocking revelation: Andromeda is coming for us. For decades, scientists wondered, what does Andromeda's movement toward us mean? In the early 20th century, astronomers realized that Andromeda is not just drifting in space. It is on a direct collision course with the Milky Way. Using data from the Hubble Space Telescope, scientists confirmed that in about 4.5 billion years, Andromeda and the Milky Way will collide in a cosmic event of unimaginable proportions. Unlike smaller galactic mergers, this will be a collision of two giant spiral galaxies, reshaping the very fabric of our local universe. The Andromeda catastrophe is not just a distant possibility. It is inevitable. The Andromeda Galaxy is not just our closest galactic neighbor, it is also our greatest cosmic threat. Scientists have confirmed that it is on a direct collision course with the Milky Way. But what does that mean for us? What happens when two giant galaxies collide? KECAP 1. The approach, Andromeda, is already on its way. Although 4.5 billion years seems like an eternity, Andromeda's approach is already visible in our telescopes. The Hubble Space Telescope confirmed that Andromeda is moving toward us at 110 kilometers per second, 68 miles per second. It will take billions of years, but the pull of gravity ensures that nothing can stop this cosmic crash. Despite its enormous distance, Andromeda takes up more space in the night sky than the Moon. If human eyes were sensitive enough, we would already see it looming over us. Andromeda is coming. The question is, what happens next? KECAP 2. The first impact, a galaxy-wide shockwave. In about 4 billion years, Andromeda and the Milky Way will begin their first violent interaction. Their outermost gas clouds and dust will collide first, triggering an explosion of star formation across both galaxies. As the galaxies pass through each other, gravitational forces will stretch and warp their once orderly spiral structures. Stars will be thrown out of their original orbits, creating long tidal tails of displaced solar systems. But what about our own solar system? Scientists believe that the chances of the Sun directly colliding with another star are very low. However, our entire solar system could be flung into a different region of the galaxy, altering our position in space forever. Earth may survive, but the galaxy we know will never be the same again. KECAP 3. The second encounter, the death of the spiral arms. As the galaxies continue their cosmic dance, the destruction will escalate. Over the next hundreds of millions of years, Andromeda and the Milky Way will collide multiple times, each pass bringing more chaos. Their once distinct spiral arms will be completely shredded, turning the two galaxies into a chaotic mass of gas and stars. The supermassive black holes at the center of each galaxy will be drawn toward each other, setting the stage for a colossal merger. This is no longer just a galactic collision. This is the transformation of two galaxies into something entirely new. KECAP for the final merger, the birth of Milkomeda. Eventually, after millions of years of destruction, the chaos will settle into something new. The Milky Way and Andromeda will fully merge into a single, giant elliptical galaxy. Astronomers call this hypothetical future galaxy Milkomeda, a new cosmic titan born from the wreckage of two spirals. Our one-spiral galaxy will be gone forever, replaced by a smooth, glowing mass of stars. But what about the fate of our Sun and Earth? By this time, the Sun will be nearing the end of its life, expanding into a red giant. If Earth still exists, it will likely be burned to a cinder or swallowed by the dying Sun. Any surviving remnants of humanity may have moved to other worlds long before this happens. For humans, the Andromeda collision may be the least of our concerns. The survival of our species will depend on how far we've advanced in space exploration by then. KECAP 5. What about the black holes? Perhaps the most dramatic event in this collision is what happens to the supermassive black holes at the heart of each galaxy. Andromeda's black hole is 100 million times the mass of the Sun, much larger than the one in the Milky Way. As the galaxies merge, these two monsters will be pulled toward each other, creating a binary black hole system. Over millions of years, their orbits will shrink, and they will eventually collide in a final, titanic explosion. The merging of these black holes will send powerful gravitational waves across the universe, marking the end of an era. KECAP 6. Could Earth survive this cataclysm? The good news? The Andromeda collision won't instantly destroy Earth. Space is so vast that stars are unlikely to physically collide. Our solar system may simply drift into a new part of the galaxy, unaffected by the destruction around it. But if we don't find a way off Earth, we may not be around to witness it. The Sun's death will happen before the galactic merger is complete. By the time Milkomeda is born, will humanity still exist? And if we do, where will we be? The Andromeda Milky Way collision may be billions of years away, but astronomers are studying it right now. Every year, new discoveries about Andromeda reshape our understanding of galaxy mergers, black holes, and even the fate of our own solar system. KeyCap One How scientists are studying Andromeda today. With modern telescopes and deep space technology, scientists can track Andromeda's movements with unprecedented accuracy. The Hubble Space Telescope has captured detailed images of Andromeda, revealing its billions of stars, dust lanes, and satellite galaxies. The James Webb Space Telescope, JWST, is analyzing Andromeda's infrared emissions, providing insights into its star-forming regions and hidden black hole activity. AI-based simulations are modeling how Andromeda's gravitational pull will shape the local group of galaxies over the next billion years. Andromeda is not just a galaxy. It's a giant cosmic laboratory, helping us understand the past and future of the universe. KeyCap 2 The Hidden Structure of Andromeda, a galactic cannibal. Recent discoveries have revealed that Andromeda is far more violent than previously thought. Astronomers have found that Andromeda has absorbed multiple smaller galaxies in the past, leaving behind stellar streams, long trails of stars ripped from their original homes. These findings suggest that our neighbor is a galactic cannibal, consuming any smaller galaxies that stray too close. Scientists predict that the Milky Way might already be falling under Andromeda's gravitational influence, pulling us toward an inevitable fate. Could the Milky Way be Andromeda's next meal? KeyCap 3 The Mystery of Andromeda's Black Hole. At the heart of Andromeda lies one of its most dangerous and mysterious features, a supermassive black hole, far larger than the one in the center of the Milky Way. Observations suggest it has ingested massive amounts of material, possibly from its past galactic mergers. Some scientists believe that Andromeda's black hole could become even more powerful after colliding with the Milky Way's black hole. The power of this cosmic monster may determine the fate of the future Milkomeda galaxy. KeyCap for the expanding universe and the fate of Andromeda. Andromeda may be heading toward us, but there's a bigger cosmic question at play. The universe is expanding, pushing galaxies away from each other. However, Andromeda and the Milky Way are bound by gravity, strong enough to resist cosmic expansion. Some scientists speculate that if the expansion of the universe accelerates, Andromeda could be affected in unexpected ways, potentially altering its course over billions of years. The more we learn about Andromeda, the more we realize how much we still don't know. KeyCap 5 Could we escape the collision? The future of human exploration. If humanity still exists in 4 billion years, could we survive the Andromeda Milky Way collision? Interstellar travel could allow future civilizations to leave the Milky Way and settle in another galaxy. Some scientists believe that if we develop advanced propulsion systems, we could relocate to a safer part of the universe before the galactic merger happens. The question remains, will humanity be ready to leave Earth long before this cosmic disaster unfolds? The Andromeda catastrophe may not be our biggest threat. The real question is, how far will humanity go before it happens? The Andromeda Galaxy is not just our closest galactic neighbor. It is a force of cosmic transformation. For centuries, it has been a beacon of wonder in the night sky, but now we know it carries the seeds of a cataclysmic future. This collision is inevitable. The Milky Way and Andromeda will merge, forming a new giant elliptical galaxy, Milkomeda. Our familiar night sky will be lost, replaced by a chaotic new cosmic order. But what does this mean for humanity's place in the universe? If we survive long enough, will we witness this event firsthand? Will we have moved beyond Earth, settling on new worlds and distant galaxies? Or will we become just another lost species, disappearing before the cosmic dance even begins? Andromeda's fate is sealed, but humanity's fate is still unwritten. As we continue exploring the universe, studying distant galaxies, and advancing our knowledge of space travel, one question remains. Will we be here to witness the birth of Milkomeda? For centuries, we have looked at the night sky and wondered, what lies beyond our cosmic neighborhood? Is the solar system just a tiny island in a vast cosmic ocean? What strange worlds, unseen forces, and unknown mysteries await us beyond the reach of our sun? Our solar system is our home in space, but it is far from the only place where wonders exist. Beyond Neptune and Pluto, the sun's influence begins to fade. At the outer edges of our system, a vast cloud of icy objects, the Oort cloud, marks the boundary between our world and the unknown. And beyond that, interstellar space, a region filled with radiation, rogue planets, and distant stars. For the first time in human history, we are beginning to explore beyond our solar neighborhood. What have we discovered so far? And what secrets still remain hidden in the endless darkness? In this documentary, we will embark on a journey to explore the history of our quest to understand what lies beyond the solar system, examine the strange and mysterious objects that exist in interstellar space, investigate how humanity is pushing the boundaries of exploration with spacecraft like Voyager and New Horizons, and ask the ultimate question: what is waiting for us beyond our own galaxy? What lies beyond the edge of the solar system? It's time to find out. For most of human history, the stars beyond our solar system remained unreachable, tiny points of light in the vast darkness. We could only speculate about what lay beyond our sun's influence. But everything changed with the rise of modern astronomy and space exploration. KECAP won the early theories, a universe beyond the sun. Long before telescopes, ancient civilizations already questioned what lay beyond the planets they could see with the naked eye. The ancient Greeks, including philosophers like Aristotle and Ptolemy, believed that the stars were fixed in a celestial sphere, a cosmic boundary that enclosed our solar system. Copernicus and Galileo shattered this idea in the 16th and 17th centuries, proving that Earth was not the center of the universe and that the sun was just one of many stars. Isaac Newton's theory of gravity suggested that the same forces governing planets also extended to the stars, hinting that our solar system was part of a much larger cosmic structure. But these were only theories. To truly explore beyond the solar system, we needed more than just ideas. We needed technology. KECAP to the birth of interstellar astronomy. The 19th and 20th centuries brought massive breakthroughs that allowed us to peer beyond the boundaries of our own solar system. 1838, Friedrich Bessel measured the first accurate distance to another star, proving that the stars were not fixed in a celestial sphere, but were scattered across a vast universe. 1901, scientists began discovering exoplanet-like objects around distant stars, long before they had the tools to confirm their existence. 1950s to 1970s, astronomers theorized the existence of the Oort cloud, a massive collection of icy objects marking the true outer boundary of our solar system. Still, no human-made object had ever ventured beyond the solar system. That would take the next great leap, the space age. KECAP 3, the space age, humanity's first attempts to leave the solar system. The mid-20th century saw the birth of space exploration, and with it, the first attempts to send probes beyond our planetary system. 1972, NASA launched Pioneer 10, the first spacecraft to head toward interstellar space. 1973, Pioneer 11 followed, capturing stunning images of Jupiter and Saturn before heading into deep space. 1977, the launch of Voyager 1 and Voyager 2, the most famous interstellar probes, forever changed our understanding of the outer solar system. Voyager 1 and 2 were not just planetary explorers. They were designed to leave the solar system entirely. 1990, Voyager 1 took the famous pale blue dot photo, showing Earth as a tiny speck in the vastness of space. 2012, Voyager 1 became the first human-made object to officially enter interstellar space, followed by Voyager 2 in 2018. For the first time, humanity had sent something beyond the solar system, into the unknown. KECAP for the true boundaries of the solar system. Most people think the solar system ends at Pluto, but in reality, our star's influence extends far beyond that. The Kuiper Belt, 30 to 50 Australian dollars from the Sun, a region filled with icy objects and dwarf planets like Pluto, Makemake, and Eris. The heliosphere, 120 Australian dollars, the bubble of solar wind that surrounds and protects the solar system. The Oort cloud, 5,000 to 100,000 Australian dollars, a massive, hypothetical shell of icy comets marking the true outer edge of our system. It takes Voyager 1 nearly 17,000 years to fully cross the Oort cloud and reach the interstellar medium, proving just how vast our own backyard in space really is. Beyond this, there is nothing but the void until we reach the stars. Summary of the historical background section. Heavy checkmark. Ancient civilizations believed in a cosmic boundary around the stars. Heavy checkmark. Astronomers in the 19th and 20th centuries proved that space extends far beyond the sun's influence. Heavy checkmark. The space age sent the first probes toward interstellar space, with Voyager 1 officially leaving the solar system in 2012. Heavy checkmark. The true boundaries of our system extend far beyond Pluto, reaching into the Oort cloud. Beyond the solar system, there are no planets, no moons, no familiar landmarks, only the endless void of interstellar space. But this void is not empty. It is filled with cosmic phenomena that challenge our understanding of the universe. What truly exists beyond the sun's influence? Let's explore the strange and mysterious objects that inhabit interstellar space. Keycap 1. The interstellar medium, the substance of space itself. Despite appearing empty, interstellar space is not a complete vacuum. It is filled with a thin, ghostly substance known as the interstellar medium. This medium is composed of hydrogen and helium gas, cosmic dust, and traces of heavier elements. It is so diffuse that a single cubic centimeter contains fewer atoms than an Earth-bound laboratory vacuum. However, these tiny particles play a critical role in star formation, as they slowly accumulate into dense clouds. The interstellar medium is the birthplace of stars and planets, a cosmic ocean from which new solar systems emerge. Keycap 2. Rogue planets, worlds without a sun. Not all planets orbit stars. Some are wanderers, rogue planets, ejected from their home systems and doomed to drift through interstellar space forever. Scientists estimate that for every star in a galaxy, there could be at least one rogue planet, meaning trillions of such worlds may exist. Some are cold and dead, frozen solid without the warmth of a sun. Others may have thick atmospheres or subsurface oceans, retaining enough heat from their formation to harbor alien life. Could some of these lost worlds still sustain life, even without a sun? Keycap 3. The closest star systems, our nearest neighbors. Once we leave the solar system, the nearest stars to us are in the Alpha Centauri system, just 4.24 light-years away. Alpha Centauri A and B, a pair of sun-like stars locked in a binary orbit. Proxima Centauri, a red dwarf that is the closest star to Earth and home to Proxima b, an exoplanet in the habitable zone. Could Proxima b be the closest Earth-like world? And what about the countless other star systems beyond? Keycap 4. Exoplanets, strange worlds orbiting alien suns. Since the 1990s, astronomers have discovered thousands of exoplanets, planets orbiting stars beyond our solar system. Some of these planets defy everything we thought we knew about planetary science. Super-Earths, planets larger than Earth but smaller than Neptune, possibly covered in vast oceans or endless rocky landscapes. Hot Jupiters, gas giants that orbit dangerously close to their stars, scorched by intense radiation. Puffy planets, worlds so large yet so light they seem like giant balloons of gas. Hell planets, planets like K2-141b, where oceans boil away and rains of molten rock fall from the sky. If these planets exist so close to us, what bizarre worlds might lie even deeper in space? Keycap 5. The interstellar highways, cosmic pathways between the stars. Despite the vast distances between stars, there are natural pathways in space that could one day be used for travel. Galactic currents, gravitational forces create streams of matter and energy flowing between stars. Interstellar winds. Particles from stellar explosions form vast, invisible currents pushing objects between star systems. Wormholes, theoretical if they exist, these shortcuts could link distant parts of the universe almost instantly. If humanity ever travels beyond the solar system, could we use these cosmic highways to shorten the journey? Keycap's 6 black holes, the cosmic abyss. Among the most terrifying objects in interstellar space are black holes, regions where gravity is so intense that not even light can escape. Some black holes form from the collapse of massive stars, creating stellar black holes. Others, like the one at the center of our galaxy, are supermassive monsters millions of times heavier than the Sun. If a spacecraft ventured too close, it would be stretched into oblivion by spaghettification, a process where gravity pulls objects apart atom by atom. Could there be entire civilizations orbiting black holes, using them as energy sources? Keycap 7, the ultimate question. Are we alone? For centuries, humans have looked to the stars and wondered, is there life beyond Earth? Some scientists believe life could be common in the universe, existing on rogue planets, exoplanets, or even in the vast interstellar medium itself. Others argue that intelligent civilizations may be incredibly rare or even extinct due to cosmic catastrophes. The Fermi paradox asks, if the universe is so vast, why haven't we found any evidence of alien life yet? What if the answer has been out there all along, waiting for us to find it? Summary of the main section. Heavy checkmark interstellar space is filled with cosmic dust, rogue planets, and exoplanets orbiting alien suns. Heavy checkmark, the nearest star system, Alpha Centauri, may hold an Earth-like world. Heavy checkmark, there are invisible cosmic highways that could one day be used for interstellar travel. Heavy checkmark, black holes and other mysterious objects pose both dangers and scientific opportunities. Heavy checkmark, the search for extraterrestrial life remains one of the biggest unanswered questions in science. For now, interstellar space remains beyond our reach. The distances are too vast, and our technology is too primitive. But will this always be the case? Could we one day send spacecraft, or even humans, beyond the solar system? Humanity has always been driven by exploration. From the first steps on the moon to robotic missions on Mars, each step has brought us closer to venturing beyond our own stellar backyard. In this chapter, we explore the theories, technologies, and challenges of interstellar travel, and what the future might hold for humanity among the stars. Keycap 1. The challenges of interstellar travel. Traveling beyond the solar system isn't just difficult. It's nearly impossible with current technology. Distance. The closest star, Proxima Centauri, is 4.24 light-years away. With today's spacecraft, it would take thousands of years to get there. Fuel and energy. Conventional rockets would need far more fuel than they can carry for such long journeys. Radiation and isolation. A human crew traveling for decades or centuries would face deadly cosmic radiation, psychological challenges, and limited resources. So, how do we overcome these challenges? Keycap 2. Future spacecraft. How we might travel beyond the solar system. Scientists and engineers are working on revolutionary propulsion systems that could one day allow us to reach other stars. A. Nuclear and fusion propulsion. Nuclear-powered rockets could be 10 times faster than chemical rockets, reducing interstellar travel time. Fusion propulsion, using the same energy that powers the sun, could push spacecraft to a fraction of the speed of light. B. Solar sails, riding the power of light. Light sails, like Breakthrough Starshot, could use lasers from Earth to push tiny probes to nearby stars within decades. These spacecraft could travel at 20% the speed of light, reaching Alpha Centauri in just 20 years. C. Antimatter engines, the ultimate power source. If we could harness antimatter, a spacecraft could reach near-light speed, making interstellar travel feasible. However, antimatter is difficult to create and store, making this technology purely theoretical for now. If we ever hope to leave our solar neighborhood, these new technologies will be the key. Keycap, 3-generation ships, traveling across centuries. If fast travel isn't possible, humanity may have to consider generation ships, massive self-sustaining spacecraft where multiple generations live and die during the journey. These ships would be miniature, self-sustaining worlds, complete with artificial gravity, farms, and ecosystems. Crews would live their entire lives aboard, passing knowledge to their descendants, who would eventually reach the destination. The biggest challenge? Social stability. Can humans survive centuries of isolation in deep space? Would future generations be willing to sacrifice their lives for a destination they will never see? Keycap, 4 colonizing exoplanets. Humanity's next home? Even if we reach another star, we still face a major challenge: finding a habitable world. The best candidate? Proxima b, an Earth-sized exoplanet in the habitable zone of Proxima Centauri. Other possibilities include super-Earths or even terraforming Mars first as a stepping stone. If a planet is not habitable, future colonists may have to live in domed cities or floating habitats orbiting distant stars. Could humanity spread across the galaxy, becoming an interstellar species? Keycap 5, the Fermi Paradox. Where is everyone? If interstellar travel is possible, then where are all the other civilizations? The Fermi Paradox asks, if the universe is full of stars and planets, why haven't we found any evidence of extraterrestrial life? Possible answers include, we are the first intelligent civilization. Life is incredibly rare. Advanced aliens exist, but they are avoiding us. Civilizations self-destruct before reaching interstellar travel. Are we truly alone, or is the universe teeming with life we simply haven't discovered yet? Keycap 6, the ultimate future, a galactic civilization. If humanity survives long enough, we could one day expand across the entire galaxy. Dyson spheres, massive structures built around stars to capture all their energy. Artificial intelligence, AI-driven spacecraft exploring the universe without humans. Post-human evolution, will we evolve into a new form of life better suited for space? The road to the stars is long, but if we succeed, we may one day call the entire galaxy our home. Summary of the future of humanity beyond the solar system. Heavy checkmark: interstellar travel is difficult but not impossible. New propulsion technologies may one day make it a reality. Heavy checkmark: generation ships and self-sustaining space habitats could help us survive long journeys. Heavy checkmark: finding a habitable exoplanet is crucial for colonization. Heavy checkmark: the Fermi Paradox remains a mystery. If life exists, why haven't we found it? Heavy checkmark: in the distant future, humanity could spread across the galaxy, becoming a truly interstellar species. For now, we remain bound to our solar system. Our home is a single planet, orbiting a single star in a single galaxy. But this is just the beginning of our story. Humanity is at a crossroads. We have sent spacecraft beyond our solar system, but they are still only in the earliest stages of interstellar travel. We have found thousands of exoplanets, but we have yet to set foot on any of them. We continue to search for extraterrestrial life, but the universe remains silent. Yet, we are still learning, still pushing forward, still reaching for the stars. Keycap 1, what we've discovered so far. In this journey beyond the solar system, we have explored. Heavy checkmark: the boundaries of our own system, including the Oort cloud and interstellar space. Heavy checkmark: the mysteries of the interstellar medium, rogue planets, and cosmic highways. Heavy checkmark: the incredible variety of exoplanets, some of which could be habitable. Heavy checkmark: the challenges of interstellar travel and the technologies that might one day take us beyond our home system. Heavy checkmark: the great question of extraterrestrial life and the paradox of why we haven't found it. Each of these discoveries brings us closer to understanding our place in the universe. Keycap 2, the future of exploration, our next steps. What happens next? We continue to search for habitable exoplanets, and perhaps even send robotic probes to study them. We develop new propulsion technologies, bringing interstellar travel closer to reality. We keep listening for signals from other civilizations, hoping to answer the question, are we alone? And one day, perhaps in the distant future, humanity itself will leave Earth behind, setting foot on a new world among the stars. The universe is vast, mysterious, and full of wonders waiting to be discovered. The only question is, how far will we go? Keycap 3, a final thought. The universe awaits. Humanity has always looked to the stars, from the first cave paintings of constellations to the telescopes that peer across the cosmos today. We are only at the beginning of our journey. The universe is a frontier beyond imagination. Our fate is in our hands. We can choose to remain on Earth, or we can become explorers of the cosmos. The stars are calling. Will we answer? Final summary. The destiny of humanity among the stars. Heavy checkmark: the solar system is only the beginning. We are part of something much bigger. Heavy checkmark: interstellar space is a vast, mysterious place filled with rogue planets, exoplanets, and cosmic wonders. Heavy checkmark: we are developing the technology to one day explore beyond our solar system. Heavy checkmark: the search for alien life continues, but for now, the universe remains silent. Heavy checkmark: our future lies among the stars, if we dare to take the next step. In the heart of our galaxy, hidden beyond clouds of cosmic dust and swirling stars, lies one of the greatest mysteries of the universe, a supermassive black hole. An object so powerful, so enigmatic, that it bends the very fabric of space and time. A region where the laws of physics, as we know them, break down, and nothing, not even light, can escape its grasp. For centuries, humanity has looked to the night sky, wondering what lies beyond the shimmering constellations. Ancient civilizations saw celestial gods and mythical creatures, while modern astronomers see something far more astounding: a singularity, a void of infinite density. But what exactly is a black hole? How did it come to exist? And what role does it play in shaping the very galaxy we call home? The idea of a black hole was once a mere mathematical curiosity, a thought experiment born from the mind of Albert Einstein. But today, we know that these objects are real, and the one lurking at the center of our Milky Way, Sagittarius A*, is over 4 million times the mass of our Sun. Its immense gravity shapes the motion of countless stars, dictating the dance of the galactic core. But despite its influence, this black hole remained hidden for decades, an invisible giant lurking in the shadows. That is, until recent breakthroughs allowed us to capture its first-ever image, a feat once thought impossible. This is a journey into the unknown, a journey to uncover the secrets of the cosmic abyss, to explore the invisible forces that sculpt galaxies and challenge our understanding of reality itself. So join us as we venture into the depths of space, to witness the heart of darkness at the center of our own Milky Way. Welcome to the story of Sagittarius A*, the black hole at the center of our galaxy. The story of black holes begins long before we had the tools to see them. It starts with a question as old as astronomy itself. What happens when a star dies? In the late 18th century, long before Einstein's revolutionary theories, English scientist John Michel and French mathematician Pierre-Simon Laplace speculated about the existence of dark stars, objects so massive that their gravitational pull would be too strong for even light to escape. At the time, it was little more than a theoretical exercise. No one could have imagined that such objects actually existed. Then, in 1915, Albert Einstein unveiled his groundbreaking theory of general relativity, forever altering our understanding of gravity. Instead of an invisible force pulling objects together, Einstein described gravity as the warping of space-time itself. The greater the mass, the greater the curvature of space. Just a year later, physicist Karl Schwarzschild took Einstein's equations a step further, describing what we now call the Schwarzschild radius, the point where gravity becomes so strong that nothing, not even light, can escape. a singularity, a black hole. But for decades, black holes remained an abstract concept. Many scientists doubted that such extreme objects could exist in the real universe. It wasn't until the mid-20th century, with the rise of powerful telescopes and radio astronomy, that the first indirect evidence began to emerge. In the 1960s, astrophysicists Jocelyn Bell Burnell and Anthony Hewish detected mysterious, rapidly spinning neutron stars, pulsars, suggesting the existence of compact, high-gravity remnants of dead stars. Around the same time, scientists discovered Cygnus X-1, a powerful X-ray source 6,000 light-years away. It became the first widely accepted black hole candidate, providing the first real-world evidence that such objects weren't just theoretical. Theoretical physicist Stephen Hawking further revolutionized our understanding of black holes, proving that they weren't entirely black at all. His work on Hawking radiation suggested that black holes slowly evaporate over time, a concept that continues to challenge physicists today. But even as evidence grew, one question remained unanswered. If black holes exist, should there not be one at the center of our own galaxy? By the 1990s, astronomers turned their attention to Sagittarius A*, a mysterious and powerful radio source at the core of the Milky Way. Using high-powered telescopes, researchers observed something incredible: stars whipping around an invisible point at mind-boggling speeds, some completing an entire orbit in just a few years. The only explanation? A supermassive black hole. It would take decades of technological advancement and international collaboration to finally bring this cosmic giant into focus. But in 2019, history was made when astronomers captured the first-ever image of a black hole, an achievement that paved the way for an even greater challenge: imaging the one at the heart of our own galaxy. For decades, scientists suspected the presence of a supermassive black hole at the heart of our galaxy. But how do you study something that, by definition, emits no light? The answer lies in its gravitational influence and the light it bends around itself. The evidence: watching stars dance around the invisible. The key to confirming the existence of Sagittarius A** was watching the motion of stars near the galactic center. In the 1990s, two independent research teams, one led by Reinhard Genzel and the other by Andrea Ghez, began tracking the orbits of individual stars around the Milky Way's core. The most striking discovery was S2, a star that orbits Sagittarius A** in just 16 years. At its closest approach, S2 moves at over 25 million kilometers per hour, faster than any other known star. Such speeds could only be explained by the presence of a black hole 4 million times the mass of our Sun. In 2020, Genzel and Ghez were awarded the Nobel Prize in Physics for their groundbreaking work, proving that a supermassive black hole truly lies at the heart of our galaxy. Imaging the unseeable, the first-ever picture of a black hole. Despite overwhelming evidence, a direct image of Sagittarius A** remained elusive. Black holes, after all, are invisible, but they do cast a shadow. In 2019, an international collaboration known as the Event Horizon Telescope, EHT, made history by capturing the first-ever image of a black hole, the now famous glowing ring surrounding the supermassive black hole in the galaxy M87. This stunning achievement set the stage for an even greater challenge: imaging our own galactic black hole, Sagittarius A*. By linking telescopes across the world, from Hawaii to Antarctica, the EHT team created a virtual telescope powerful enough to resolve details the size of a golf ball on the moon. However, unlike M87's black hole, which is a monstrous 6.5 billion times the Sun's mass, Sagittarius A** is much smaller, making it harder to capture. The breakthrough: revealing Sagittarius A**. After years of data processing, in May 2022, astronomers finally unveiled the first-ever image of Sagittarius A*. It looked eerily similar to M87's black hole, a glowing ring of superheated gas circling an empty void. But this wasn't just a photograph. It was proof that black holes follow Einstein's predictions, even under the most extreme conditions. The anatomy of a black hole. What lies beyond the event horizon? So, what exactly happens inside a black hole? A black hole is defined by its event horizon, the point of no return. Anything that crosses this boundary, whether a planet, a star, or even light itself, is lost forever. At the center lies the singularity, a point of infinite density where the known laws of physics break down. Einstein's equations predict that space and time themselves collapse here, creating one of the greatest mysteries in modern physics. Physicists have long struggled to reconcile general relativity, which describes gravity on cosmic scales, with quantum mechanics, which governs the subatomic world. Black holes sit at the crossroads of these two fields, hinting at a deeper, unified theory of the universe. How black holes shape the universe. Despite their ominous reputation, black holes are not just cosmic vacuum cleaners sucking up everything in their path. In fact, they play a vital role in galactic evolution. Galactic architects. The immense gravitational pull of black holes helps structure galaxies, influencing star formation and the distribution of matter. Quasars and jets. Some black holes power the most energetic objects in the universe. Quasars, which shine brighter than entire galaxies, and relativistic jets, which blast matter across intergalactic space. Time machines. Due to extreme gravitational time dilation, an observer falling into a black hole would experience time slowing down relative to the outside universe. In theory, black holes could provide insight into time travel and the nature of spacetime itself. As we continue to unlock the secrets of black holes, we're left with even bigger questions. What happens to the information that falls into a black hole? Could black holes lead to parallel universes? And could they hold the key to understanding the very origins of space and time? For centuries, black holes were the realm of theory, enigmatic voids lurking at the edges of our understanding. But today, they are no longer just mathematical abstractions. They are observable, measurable, and deeply influential in shaping the cosmos. The discovery and imaging of Sagittarius A* was a monumental achievement, but it was only the beginning. Scientists are now racing to answer new, profound questions about these cosmic titans, refining the image beyond the first glimpse. While the Event Horizon Telescope, EHT, provided the first-ever image of Sagittarius A*, the resolution was limited. Unlike the relatively stable black hole in M87, Sagittarius A* is much more dynamic. The swirling plasma around it changes on timescales of minutes, making it harder to capture a single, clear snapshot. To improve the resolution, scientists are now expanding the EHT network with more telescopes and more precise instruments. Future observations will reveal real-time videos of matter spiraling into the event horizon, giving us an unprecedented look at the violent forces at play. Probing the physics, general relativity versus quantum mechanics. Despite the success of Einstein's general relativity in predicting the behavior of black holes, there are still gaps in our understanding. General relativity describes black holes as infinitely dense singularities, but quantum mechanics suggests that information cannot be destroyed. Hawking radiation, proposed by Stephen Hawking, implies that black holes slowly evaporate, but how this process works remains a mystery. The information paradox, a fundamental puzzle, questions whether information that falls into a black hole is lost forever or somehow preserved. To address these challenges, physicists are exploring theories such as quantum gravity and string theory, which attempt to unify general relativity with quantum mechanics. Some theories propose that black holes could be holographic projections or even gateways to other dimensions. Supermassive black holes and the evolution of galaxies. Sagittarius A* isn't just an isolated object. It plays a crucial role in the evolution of the Milky Way. Observations suggest that supermassive black holes and galaxies co-evolve, meaning their growth is interconnected. Black hole mergers, driven by galactic collisions, may trigger bursts of star formation or quench star formation entirely. The Milky Way Andromeda collision, set to happen in about 4.5 billion years, could result in a much larger black hole at our galactic center. By studying Sagittarius A*, scientists hope to uncover the broader role of black holes in shaping the large-scale structure of the universe. New tools for exploration, next-gen telescopes, and space missions. The next decade will usher in a new era of black hole research, powered by cutting-edge observatories and space missions. The James Webb Space Telescope, JWST, is already providing deep infrared views of the galactic core, helping us study black hole accretion disks and surrounding dust clouds. The Square Kilometer Array, SK, set to be the most powerful radio telescope ever built, will map the formation of early black holes in unprecedented detail. Future space missions like LISA, Laser Interferometer Space Antenna, will detect gravitational waves from colliding black holes, offering new ways to observe these enigmatic objects. The search for the unknown, exotic black hole theories. As technology advances, so do the questions. Could some black holes be primordial, formed in the early universe before stars even existed? Do naked singularities, where space collapses without an event horizon, actually exist? Could some black holes harbor wormholes, linking distant parts of the universe? These questions push the limits of our understanding, challenging the very fabric of physics. The discovery of black holes has reshaped our understanding of the universe. But for all we have learned, the greatest mysteries remain unsolved. What lies beyond the event horizon? Can we ever fully understand the physics of the singularity? And could black holes hold the key to unlocking the fundamental nature of reality itself? The future of black hole research is more exciting than ever, driven by new technologies, ambitious space missions, and groundbreaking theories that could redefine our place in the cosmos. Building a better picture, the next generation of telescopes. Capturing the first image of Sagittarius A* was just the beginning. Scientists are now working to create real-time movies of black holes in action, revealing how matter falls into the event horizon and how these cosmic giants evolve over time. The next-generation Event Horizon Telescope, ENIHD, will use space-based radio telescopes to dramatically improve resolution, allowing us to see the fine details of black hole dynamics. The upcoming Lynx X-ray Observatory will probe high-energy interactions near event horizons, helping us understand how black holes feed and grow. With these new tools, we may finally uncover the true nature of the extreme environments surrounding black holes. Gravitational waves, listening to black holes collide. Until recently, black holes were silent, invisible giants that could only be inferred through indirect observations. But with the advent of gravitational wave astronomy, we can now listen to black holes colliding. The LISA mission, Laser Interferometer Space Antenna, launching in the 2030s, will detect gravitational waves from merging supermassive black holes across the universe. These signals will allow us to map black hole mergers over cosmic time, tracing the formation of galaxies billions of years ago. Each new detection brings us closer to answering fundamental questions. How do black holes grow? How often do they merge? And could these collisions produce entirely new forms of matter or energy? The quest for the theory of everything. Black holes are more than just celestial objects. They are cosmic laboratories for testing the most extreme physics in existence. Einstein's general relativity describes black holes on large scales, but breaks down at the singularity. Quantum mechanics governs the microscopic world but struggles to explain gravity. A true theory of quantum gravity, a theory of everything, must unify these two realms. Some scientists believe that black holes might be the key to this missing theory. Could space-time itself be made of quantum information? Could black holes be holograms? These questions challenge the very foundation of physics. Exotic possibilities. Black holes, wormholes, and parallel universes. While Einstein's equations predict black holes, they also allow for wormholes, hypothetical tunnels through space-time. If wormholes exist, they could serve as shortcuts across the universe or even gateways to parallel dimensions. Other radical ideas suggest that black holes might be portals to new universes, with each black hole in our cosmos birthing a separate reality on the other side. These ideas remain speculative, but the more we learn about black holes, the more we realize how much we don't know. What happens next? The coming decades will be a golden age for black hole research. With new telescopes, deep space probes, and gravitational wave observatories, we are on the brink of revolutionary discoveries. One thing is certain. The deeper we look into the darkness of black holes, the closer we come to unlocking the ultimate secrets of the universe itself. For centuries, black holes existed only in the minds of theorists, mathematical ghosts haunting the edges of physics. Today, they are real, observable, and more mysterious than ever. The journey to understand Sagittarius A** has been one of humanity's greatest scientific achievements. From the first mathematical predictions to the historic images captured by the Event Horizon Telescope, we have come closer than ever to deciphering the secrets of these cosmic enigmas. But black holes are more than just objects of scientific curiosity. They shape the universe, guiding the evolution of galaxies, influencing the birth of stars, and challenging our understanding of space-time itself. And yet, for all we know, the biggest questions remain unanswered. What happens at the singularity? Can black holes lead to new dimensions or even new universes? Could they hold the key to a deeper, unified theory of reality? The next frontier of exploration awaits. Future telescopes, space missions, and breakthroughs in quantum physics will bring us closer to answers. But perhaps the greatest discovery lies not in what we already know, but in what we have yet to even imagine. The universe is vast, mysterious, and full of wonders yet to be revealed. And at its core, the black hole of Sagittarius A* reminds us that some of the greatest discoveries lie not in what we can see, but in what we dare to explore. In the vast expanse of space, countless mysteries remain unsolved by science. Despite rapid technological advancements and constant scientific discoveries, the universe continues to surprise and perplex even the most brilliant minds of our time. The more we learn about the cosmos, the more we realize how little we know, notes Professor Brian Greene, a theoretical physicist at Columbia University. Every new discovery brings dozens of new questions, and that's beautiful. It's how science progresses. In this article, we will explore 10 of the most intriguing cosmic mysteries that remain unsolved and present insights from leading experts in astrophysics and cosmology. 1. Dark matter, the invisible ruler of galaxies. In the early 1930s, Swiss astronomer Fritz Zwicky observed an anomaly while studying the motion of galaxies in the Coma Cluster. The galaxies were moving much faster than expected based on their visible mass. This observation marked the beginning of one of modern astrophysics' greatest mysteries, dark matter. Dr. Vera Rubin, whose groundbreaking research in the 1970s provided crucial evidence for dark matter, once said, "There is nothing in nature more mysterious than dark matter. We can observe its influence everywhere, but we cannot see it directly." Modern research and hypotheses. Professor Lisa Randall from Harvard University, a leading expert on dark matter, explains, "We know dark matter exists thanks to numerous independent observations, from galaxy motion to gravitational lensing. The question is not whether it exists, but what it actually is." According to current estimates, visible matter makes up only about 5% of the universe's mass. Approximately 27% is attributed to dark matter, which we cannot see directly but can observe through its gravitational effects on visible matter. Imagine watching a couple dance in a completely dark room, where only one dancer is visible, says Dr. Catherine Fries, head of the LUX Dark Matter Detection Experiment. You can infer the presence of the second dancer by the movements of the first. That's how we detect dark matter, by its influence on visible matter. ongoing searches. Large-scale experiments are currently underway to directly detect dark matter particles. One of the largest detectors, Xenon 1T, is located in the Gran Sasso Underground Laboratory in Italy. We use ultra-pure liquid xenon as a target, explains Dr. Elena April, coordinator of the Xenon project. If a dark matter particle collides with a xenon nucleus, we can detect a tiny flash of light and an electrical signal. So far, we haven't found any dark matter particles, but each experiment brings us closer to solving the mystery. 2. Dark energy, the mysterious force of expansion. The discovery of the universe's accelerated expansion in 1998 shocked the scientific community. Saul Perlmutter, Brian Schmidt, and Adam Rees, who received the Nobel Prize for this discovery, found that galaxies are moving away from each other faster and faster, as if pushed by some invisible force. The nature of dark energy. Dark energy is perhaps the greatest mystery in modern physics, says Nobel laureate Adam Rees. It makes up about 68% of the universe's mass energy, but we know almost nothing about its nature. It's like discovering that most of your house is made of something invisible and incomprehensible. Professor Lawrence Krauss, author of A Universe from Nothing, adds, quantum field theory predicts the existence of vacuum energy, but its calculated value differs from the observed dark energy by 120 orders of magnitude. This is the largest discrepancy between theory and experiment in the history of physics. Current research. Dr. Rachel Bean from the Kitt Peak Observatory discusses the new dark energy spectroscopic instrument DESI project. We're creating a 3D map of the universe by measuring distances to millions of galaxies and quasars. This will help us better understand how dark energy influences the universe's expansion over time. Professor Sean Carroll from Caltech offers an intriguing perspective. Perhaps dark energy isn't just a cosmological constant, but a dynamic field that changes over time. If so, the fate of the universe could be far more complex and interesting than we think. 3. Baryon asymmetry. Why does matter exist? Professor Andre Linde, one of the creators of cosmic inflation theory, begins the discussion of this mystery with a philosophical question. Why do we exist at all? According to the laws of physics, matter and antimatter should have completely annihilated each other after the Big Bang. But something went wrong, and that's why we're here. Symmetry breaking. In the early universe, for every billion particle-antiparticle pairs, there was one extra particle of matter, explains Dr. Helen Quinn from SLAC National Accelerator Laboratory. This tiny asymmetry is the reason everything we see around us exists. Searching for explanations. Dr. Tsutomu Yanagita from the University of Tokyo, known for his work on baryon asymmetry generation, comments, we're looking for processes that could have broken the symmetry between matter and antimatter in the early universe. One possible mechanism is leptogenesis, involving heavy neutrinos. Professor Sakharov, whose conditions for baryon asymmetry became foundational in this field, once noted 3 necessary conditions: baryon number violation, C, and CP symmetry violation, and deviation from thermal equilibrium. The standard model of particle physics cannot explain the observed asymmetry, says Dr. Marcela Carina from CERN. CP violation in weak interactions is too small. We're searching for additional sources of CP violation in new particles and interactions. 4. Ultra-high energy cosmic rays. Where do they come from? Imagine a tennis ball with the energy of a large truck moving at full speed, describes Professor James Cronin, a Nobel laureate and co-founder of the Pierre Auger Observatory. That's the kind of energy some cosmic rays carry. And we have no idea what could accelerate particles to such energies. The origin paradox. Dr. Angelo Alinto, a leading cosmic ray researcher, explains, according to the GZK effect, ultra-high energy cosmic rays cannot come from distances greater than 100 megaparsecs. But within this radius, we don't see any objects capable of producing them. It's a real paradox. Modern observations. The Pierre Auger Observatory in Argentina records particle cascades created when cosmic rays collide with the atmosphere, says Dr. Karl-Heinz Kamper. We can determine the primary particle's energy and approximate direction, but the sources remain a mystery. 5. Magnetic monopoles, elusive particles. In 1931, Professor Paul Dirac mathematically showed that the existence of magnetic monopoles would explain the quantization of electric charge. The beauty of this idea lies in its simplicity, comments Professor Joseph Wilczynski. If even one magnetic monopole exists in the universe, it would be enough to explain charge quantization. Experimental searches. We've searched for monopoles in cosmic rays, accelerators, lunar samples, and ancient mica, says Dr. Arda Rajani from the MOEDL experiment in CERN. So far, no luck, but the absence of evidence isn't evidence of absence. Professor Alan Guss, author of Cosmic Inflation Theory, suggests inflationary expansion in the early universe might have diluted the concentration of monopoles so much that finding them is nearly impossible. 6. Cosmic voids, giant emptiness in the universe's structure. Voids challenge our understanding of the universe's large-scale structure, says Professor Yelena Nikolek from the Max Planck Institute for Astrophysics. Some are so large that they shouldn't have had time to form in the universe's lifetime. The cold spot mystery. Dr. Istvan Saputty, who studies the largest known cosmic void, comments, the cold spot in the cosmic microwave background might be linked to a giant void. But its size, about 1.8 billion light-years, is hard to explain within the standard cosmological model. New theories. Perhaps voids aren't just empty spaces, suggests Professor Laura Mersini-Houghton. They might be filled with dark energy or exotic matter, influencing the universe's large-scale structure. 7. The cosmological lithium problem. The discrepancy between predicted and observed lithium. 7 levels is one of modern cosmology's most intriguing mysteries, notes Professor Gary Steigman, an expert on primordial nucleosynthesis. Searching for solutions. Dr. Karen Lin from the Max Planck Institute for Astronomy explains, we carefully measure lithium content in the galaxy's oldest stars. The results consistently show a lithium deficit compared to theoretical predictions. Perhaps some lithium was destroyed by unknown processes in the early universe, suggests Professor Brian Fields. Or maybe we're missing something in our understanding of primordial nucleosynthesis. 8. The ultraviolet catastrophe of the early universe. Reionizing intergalactic hydrogen requires an enormous amount of energy, explains Professor Stephen Finkelstein. But known ultraviolet sources from that period can't provide the necessary power. Searching for ionization sources. Dr. Emma Chapman from MIT comments, we're studying the first galaxies with the James Webb Space Telescope. Perhaps early stars were more massive and hotter than we thought. Exotic sources might also be involved, adds Professor Abraham Wall. For example, dark matter particle annihilation or mini-quasars could have contributed significantly to reionization. 9. The horizon problem. The mystery of cosmic uniformity. The uniformity of the cosmic microwave background is one of cosmology's most astonishing mysteries, says Professor Andre Lugo. Different regions of space have nearly identical temperatures, even though they could never have exchanged information. Inflation theory. Cosmic inflation offers an elegant solution to the horizon problem, explains Professor Alan Guss. But the nature of the inflating field and the mechanism stopping inflation remain unknown. Dr. Eva Silverstein adds, some versions of inflation theory predict a multiverse. It's an exciting idea, but it's impossible to test experimentally. 10. Quantum gravity. The search for a final theory. Quantum gravity is the holy grail of modern physics, declares Professor Carlo Rovelli, one of the creators of loop quantum gravity theory. We're trying to unify quantum mechanics and general relativity, but these theories speak different mathematical languages. String theory and alternatives. String theory is the most developed candidate for a quantum theory of gravity, says Professor Edward Witten. But there's no way to experimentally test its predictions yet. Professor Lee Smolin offers an alternative view. Perhaps we need to radically rethink our understanding of space, time, and causality at the fundamental level. Conclusion. These 10 mysteries show how astonishing and enigmatic our universe remains, concludes Professor Brian Greene. Each one could lead to a revolution in physics and our understanding of the cosmos. Dr. Neil deGrasse Tyson adds, "The history of science teaches us that the greatest discoveries often come from tackling the hardest puzzles. Solving one of these mysteries might open the door to a completely new understanding of the universe." In the end, says Professor Steven Weinberg, the most amazing thing about cosmic mysteries is that we can study them and gradually approach their solutions. This demonstrates the incredible capacity of the human mind to comprehend the laws of nature. For centuries, humanity has sought out the wonders of the world, monuments, landscapes, and structures that captivate the imagination. But beyond Earth, in the vast expanse of space, lie even greater marvels. From colossal storms that have raged for centuries to moons with underground oceans, our solar system is home to some of the most extraordinary and breathtaking phenomena ever discovered. Imagine a world where volcanoes erupt with molten sulfur, spewing fire into the vacuum of space. Picture an ice-covered moon with an ocean so deep it could hide life beneath its frozen shell. What about a storm so large that it could swallow Earth several times over? These are not the fantasies of science fiction. They are real places orbiting the same sun as Earth, waiting to be explored. In this journey, we will take you across the solar system to uncover its 7 greatest wonders. Places that defy imagination, challenge science, and hold the potential to rewrite our understanding of the cosmos. Prepare for an adventure beyond Earth. These are the 7 wonders of the solar system. Keycap 1: Ancient Observations. The first planetary discoveries. Before the invention of telescopes, early civilizations tracked the movements of the planets with the naked eye. The Babylonians, Greeks, and Chinese recorded the strange patterns of Mars, Jupiter, and Saturn, trying to understand their purpose. The Greeks believed the planets were gods moving across the sky. The Maya civilization developed highly advanced astronomical charts, accurately predicting planetary movements. The Romans named the planets after their deities: Mars, Venus, Jupiter, and beyond. But these early observations only scratched the surface. The true scale and complexity of the solar system remained a mystery. Keycap 2: The invention of the telescope, a new cosmic perspective. Everything changed in 1609 when Galileo Galilei pointed his telescope at the planets. He saw craters on the moon, proving that celestial bodies were not perfect spheres. He discovered Jupiter's 4 largest moons, Io, Europa, Ganymede, and Callisto, revealing that other planets had their own systems. He observed Saturn's rings, though he didn't yet understand what they were. His discoveries shattered the old beliefs that Earth was the center of the universe. The planets were worlds of their own, and the mysteries they held were beyond imagination. Keycap 3: The Space Age, the first close-up views of other worlds. For centuries, astronomers could only guess what lay on the surfaces of these distant planets. But with the rise of the space age, everything changed. 1965, NASA's Mariner 4 sent back the first ever close-up images of Mars, revealing a barren, cratered world. 1979, the Voyager probes flew past Jupiter and Saturn, capturing stunning images of swirling storms and intricate ring systems. 2005, the Cassini mission explored Saturn's moons, discovering liquid methane lakes on Titan and icy geysers erupting from Enceladus. These missions transformed our knowledge of the solar system. What once seemed like distant dots of light were now diverse and alien worlds, each more strange and wonderful than the last. Keycap 4: Today's exploration, unraveling the mysteries of the cosmos. Today, humanity stands at the edge of a new era of space exploration. The Perseverance rover is searching for signs of ancient life on Mars. The James Webb Space Telescope is scanning the atmospheres of distant exoplanets. Future missions are preparing to send humans to the Moon and Mars, paving the way for deeper space travel. But the solar system is still full of mysteries waiting to be uncovered. Some places seem so extreme, so otherworldly, that they feel like something out of science fiction. These are the seven wonders of the solar system. Places so incredible that they redefine what we know about planets, moons, and the very nature of the universe. Olympus Mons, the tallest volcano in the solar system, Mars. Height, 22 kilometers, 13.6 miles, nearly 3 times taller than Mount Everest. Width, 600 kilometers, 373 miles, covering an area larger than France. Age, over a billion years old. Olympus Mons is the largest volcano and one of the most mysterious features on Mars. Scientists believe it was formed by millions of years of eruptions, with lava slowly building up its massive structure. But what makes Olympus Mons truly strange is its lack of erosion, suggesting that it may have been active in the recent geological past. Could it erupt again one day? If this volcano were on Earth, it would reach the stratosphere, piercing through the sky. Keycap 2, the Great Red Spot, Jupiter's eternal storm. Size, over 16,000 kilometers, 10,000 miles across, large enough to fit Earth inside it. Age, at least 350 years old, possibly much longer. Windspeed, over 400 mph, 644 km per uur. This gigantic storm has been raging on Jupiter for centuries. Scientists believe it was first observed in the 1600s, and yet it still remains one of the biggest mysteries of the solar system. Recent studies suggest that the Great Red Spot is shrinking, but no one knows if it will ever disappear completely. A hurricane on Earth may last a few weeks, but on Jupiter, storms can last for generations. Keycap 3, the Rings of Saturn, the most spectacular rings in space. Diameter, over 280,000 kilometers, 174,000 miles, almost the distance from Earth to the Moon. Thickness, only about 10 meters, 33 feet, in some places. Composition, ice, rock, and dust particles. Saturn's rings are one of the most stunning features in our solar system. But their true origin remains a mystery. Were they formed from a shattered moon? Or are they the remnants of the early solar system? Some scientists predict that Saturn's rings may disappear in the next 100 million years as they slowly fall into the planet due to gravity. We may be living in a rare era where Saturn's rings still exist. Keycap 4 Io, the most volcanically active world, Jupiter's moon. Surface temperature, minus 130 degrees Celsius, minus 202 degrees Fahrenheit, yet covered in active lava flows. Volcanic plumes can reach heights of 500 kilometers, 310 miles. Tidal heating, caused by Jupiter's immense gravity stretching and compressing the moon's interior. Io is a world of fire and chaos. Its surface is constantly reshaped by lava lakes, rivers of molten rock, and powerful eruptions. Scientists believe Io's extreme volcanic activity could help us understand the early Earth, when our planet was still young and covered in lava. If there's a place in the solar system that resembles hell, it's Io. Keycap 5 Enceladus, the ice moon that may harbor life. Diameter, only 500 kilometers, 310 miles, yet one of the most exciting places in the solar system. Subsurface ocean, hidden beneath a thick layer of ice. Geysers, water plumes shoot into space, rich in organic materials. In 2005, NASA's Cassini spacecraft made a shocking discovery. Geysers erupting from Enceladus's south pole, spraying water vapor, ice, and complex organic molecules into space. This moon may hold the key to discovering extraterrestrial life. If life exists in its hidden oceans, it could reshape our understanding of the universe. Could Enceladus be our best chance at finding alien life? Keycap 6 Valles Marineris, the Grand Canyon of Mars. Length, over 4,000 kilometers, 2,500 miles, longer than the United States. Depth, up to 7 kilometers, 4.3 miles, deep, deeper than Earth's Grand Canyon. Formation, believed to be caused by tectonic activity and erosion. Valles Marineris is one of the largest canyon systems in the solar system. Scientists believe it formed billions of years ago, possibly due to ancient water flows or massive planetary stress fractures. If there was ever a river on Mars, It may have once flowed through Valles Marineris. Keycap 7 Titan, Saturn's moon with rivers, lakes, and rain. Size: larger than Mercury. Atmosphere: thick with methane and nitrogen. Weather system: it rains liquid methane, creating rivers and seas. Titan is the only other world in the solar system with liquid on its surface, but instead of water, it's liquid methane. Some scientists believe Titan's chemistry could support exotic forms of life, unlike anything found on Earth. Titan is an alien world, but it may also be a second Earth in disguise. The wonders of the solar system are not just ancient relics or distant mysteries. They are active, changing, and evolving before our very eyes. With each passing year, new missions uncover secrets that redefine our understanding of these extraordinary places. Keycap 1 Mars. The search for ancient life continues. NASA's Perseverance rover is currently exploring Jezero Crater, a region that may have once been a lake. It is collecting rock samples that could contain signs of ancient microbial life. These samples will be returned to Earth through the Mars Sample Return mission, planned for the 2030s. If Mars once had lakes and rivers, could it have also had life? But Mars is not just about the past. NASA and SpaceX plan to send humans to the Red Planet in the coming decades. Could Mars one day be humanity's second home? Keycap 2 Europa and Enceladus. The best places to search for alien life. Two of the most exciting moons in the solar system are Europa, Jupiter, and Enceladus, Saturn. Both contain hidden oceans beneath their ice shells. And where there is water, there could be life. NASA's Europa Clipper mission, launching in 2024, will fly past Europa dozens of times, scanning its surface for signs of biological activity. Scientists believe hydrothermal vents on Europa's ocean floor could provide the right conditions for life, similar to those found in Earth's deep-sea trenches. Enceladus's geysers contain complex organic molecules, meaning it has all the ingredients necessary for life. Future missions might send a robotic submarine to dive into its ocean and search for alien organisms. If life exists beyond Earth, these moons could be the key to finding it. Keycap 3 Titan, a moon with a methane ocean. NASA is planning an ambitious mission to Titan called Dragonfly. Launch 2027. Arrival 2034. Mission goal: explore Titan's lakes, dunes, and atmosphere using a flying rotorcraft. Titan is unlike any other moon. It has a thick atmosphere, rain, rivers, and lakes. But instead of water, it's all made of methane and ethane. Some scientists believe that Titan's chemistry could support an exotic form of life, completely different from anything on Earth. Could we find life in Titan's alien seas? Keycap for the future of human space exploration. Humanity's next great leap is to expand beyond Earth and explore other worlds firsthand. NASA's Artemis program aims to return humans to the moon by 2025, using it as a base for deeper space missions. SpaceX is developing Starship, a spacecraft designed for long-term missions to Mars and beyond. The Lunar Gateway, an orbiting moon station, will serve as a stepping stone for interplanetary travel. The wonders of the solar system are no longer just places to observe. They are destinations waiting to be explored. Keycap 5, could there be more wonders yet to be found? Even with all our discoveries, the solar system is still full of mysteries. Could there be a hidden ninth planet lurking in the outer solar system? What secrets are buried beneath the icy crust of Pluto? Could we one day terraform Mars, making it a habitable world? As technology advances, we will continue to uncover new and unimaginable wonders. What will the next great discovery be? From towering volcanoes to icy ocean worlds, from eternal storms to methane lakes, the solar system is filled with wonders beyond imagination. These places are not just distant, lifeless rocks. They are dynamic, active, and changing worlds, each telling the story of our cosmic past, present, and future. For centuries, we have gazed at the sky in wonder. And now, with powerful telescopes, robotic explorers, and soon, human missions beyond Earth, we are beginning to truly understand our place in the universe. But the journey has just begun. Will we one day walk on Mars and explore the depths of Valles Marineris? Will robotic submarines dive into the icy oceans of Europa and Enceladus to find alien life? Will we build cities on Titan, floating above its methane seas? The wonders of the solar system are not just places to observe. They are destinations waiting to be explored. And as long as we continue to reach for the stars, we will uncover even greater mysteries hidden in the cosmos. For centuries, humans have gazed at the night sky, captivated by the celestial wonders above. Among the countless stars, one region stands out as a cosmic masterpiece, a birthplace of worlds, a cradle of stars, and a mystery yet to be fully unraveled. This is the Orion Nebula. Visible to the naked eye as a faint, glowing smudge in the constellation of Orion, this nebula is one of the most studied and photographed objects in the sky. But beyond its stunning beauty lies something even more profound, a place where new stars are born, where planetary systems take shape, and where astronomers have uncovered cosmic structures that defy explanation. What is the Orion Nebula? How did it form? And why is it so important to our understanding of the universe? Could this stellar nursery hold the building blocks of life? And what secrets are hidden within its swirling clouds of gas and dust? Join us as we journey into the heart of one of the most enigmatic and awe-inspiring regions of the cosmos, the Orion Nebula. Long before modern science, ancient civilizations looked up at the night sky and marveled at the bright constellation of Orion. To many, it was a celestial hunter, a divine figure, or a gateway to the gods. But hidden within its glowing belt and sword lay something even more remarkable, one of the largest star-forming regions in the Milky Way. Early mentions of the Orion Nebula. Although the Orion Nebula is visible to the naked eye, it was often mistaken for a faint star in ancient times. The first recorded mention comes from 1610, when the French astronomer Nicolas Claude Fabry de Peiresc noted a fuzzy, cloud-like patch in the sword of Orion. 1610, Peiresc is credited with being the first to document the nebula as a celestial cloud, not a star. 1656, Dutch astronomer Christiaan Huygens made the first detailed telescopic observations, sketching its swirling structure and noting its irregular shape and bright core. 18th century, Sir Edmund Halley, of Halley's Comet fame, formally classified it as a nebula, recognizing its gas-like nature rather than a collection of stars. But these early observations were only the beginning. The true nature of the Orion Nebula remained a mystery until astronomers developed more advanced telescopes. The Orion Nebula through the ages. As astronomy advanced, so did our understanding of the nebula's true structure. 1774, Charles Messier added the Orion Nebula to his famous catalog as Messier 42 M42, making it one of the first deep sky objects to be systematically studied. 1800s, spectroscopy revolution. Scientists like William Huggins used spectroscopic analysis to reveal that the nebula was composed not of stars, but of glowing gas, a fundamental discovery in astrophysics. 1880, the first photograph. Astrophotographer Henry Draper captured the first ever image of the Orion Nebula, proving that its intricate structure was even more complex than human eyes could perceive. With each discovery, it became clear the Orion Nebula was not just a cloud of gas. It was a cosmic nursery filled with newborn stars, planetary systems, and the very building blocks of the universe. The modern era, unveiling the Orion Nebula's secrets. The 20th and 21st centuries have brought unprecedented discoveries, thanks to advanced telescopes like Hubble Space Telescope, 1990 present, provided the most detailed images ever captured, showing swirling clouds of gas, dust, and newborn stars. Spitzer Space Telescope, 2003 to 2020, used infrared light to peer through the nebula's dust, revealing hidden planetary disks forming around young stars. James Webb Space Telescope, 2022 present, captured the clearest view yet of the nebula's inner regions, uncovering previously unseen structures and star clusters. The Orion Nebula is more than just a stunning cosmic cloud. It is an active laboratory where we can witness the birth of stars and planetary systems in real time. Why is the Orion Nebula so important? The Orion Nebula is not just another deep space object. It is a crucial site for scientific discovery, helping astronomers answer fundamental questions like, how do stars form? How do planetary systems evolve? Could the Orion Nebula contain organic molecules, the building blocks of life? But the most intriguing discoveries are yet to come. As we continue to explore this stellar nursery, new mysteries emerge, some of which challenge everything we thought we knew about the universe. Summary of the historical background section. The Orion Nebula was first recorded in 1610, but remained a mystery for centuries. Astronomers from Huygens to Messier helped classify and document its structure. Spectroscopy revealed it was a glowing gas cloud, not a collection of stars. Modern telescopes have unveiled its role as a massive, star-forming region. It continues to be a key research site for astrophysics and planetary formation. The Orion Nebula is more than just a cosmic spectacle. It is a living laboratory of star formation, a place where entire solar systems are being born. What exactly happens inside this celestial nursery? What secrets do its vast clouds of gas and dust hold? To understand the Orion Nebula, we must first look at the forces that shape it. The structure of the Orion Nebula, a giant star-forming region. The Orion Nebula, Messier 42, is one of the largest and brightest nebulae in our galaxy, stretching 24 light-years across and located 1,344 light-years away from Earth. The nebula is composed of hydrogen, helium, and trace elements, forming an immense cloud that glows due to radiation from young stars. Its massive size and proximity to Earth make it one of the best places for scientists to study stellar birth in real time. At the heart of the nebula lies the Trapezium Cluster, a group of 4 intensely bright stars that illuminate the surrounding gas. These stars are so hot and energetic that their radiation carves out cavities in the surrounding gas, triggering the birth of even more stars. How stars are born in the Orion Nebula. The Orion Nebula is a stellar nursery where massive clouds of gas and dust collapse under their own gravity, forming protostars. Step 1. Gas clouds begin to collapse. Gravity pulls together cold gas and dust, forming dense protostellar cores. As the core contracts, it heats up, eventually igniting nuclear fusion, the process that powers stars. Step 2. Protoplanetary disks appear. Around newly forming stars, rotating disks of gas and dust, called protoplanetary disks, begin to form. These disks are the building blocks of planetary systems, similar to how our solar system formed 4.6 billion years ago. Step 3. Young stars emerge. As fusion begins, the newborn stars blow away surrounding gas, revealing themselves as bright young stars. Some of these stars will become massive giants, while others will be small and dim, like red dwarfs. Right now, inside the Orion Nebula, thousands of new stars are being born, some of which may one day host planets like Earth. The mysterious Proplets, the birthplace of new solar systems. Astronomers have discovered over 150 protoplanetary disks, or Proplets, inside the Orion Nebula, disks of gas and dust surrounding young stars that may be forming planets. These Proplets are early versions of planetary systems, similar to what our solar system looked like in its infancy. The Hubble Space Telescope has captured incredible images of these swirling disks, revealing planetary formation in progress. Scientists believe that within a few million years, some of these disks will evolve into fully formed solar systems. Could one of these Proplets eventually produce a planet with life? The Orion Nebula may hold the answers. The Trapezium Cluster, a stellar powerhouse. At the heart of the Orion Nebula lies the Trapezium Cluster, a group of 4 massive, young stars that shape the surrounding gas clouds. These stars are extremely hot, emitting powerful ultraviolet radiation that ionizes the surrounding gas, making the nebula glow. Their intense stellar winds push away gas and dust, influencing the formation of nearby planetary systems. The largest of these stars will eventually explode as supernovae, enriching the nebula with heavier elements. Without these giant stars, the Orion Nebula would not be the breathtaking cosmic landscape we see today. Could the Orion Nebula contain the building blocks of life? Recent observations suggest that the Orion Nebula is rich in organic molecules, including those necessary for life. Scientists have detected complex carbon-based molecules, such as methanol, formaldehyde, and polycyclic aromatic hydrocarbons, PAHs. These molecules are the precursors to amino acids, which are the building blocks of life as we know it. The discovery supports the idea that the ingredients for life may be common throughout the galaxy. If life on Earth was seeded by cosmic molecules, could the Orion Nebula be one of the sources? The dark regions of the Orion Nebula, a hidden mystery. While the bright, glowing parts of the nebula are well studied, some regions remain shrouded in mystery. The Orion Molecular Cloud Complex, a vast, dark region behind the nebula, is one of the most active star-forming areas in our galaxy. Astronomers have detected strange filaments of gas and magnetic structures whose origins are still unknown. Some theories suggest that hidden black holes or failed stars, brown dwarfs, may be lurking in these regions. Even with our most powerful telescopes, the Orion Nebula continues to guard its secrets. Summary of the main section. What we've discovered so far. The Orion Nebula is a massive star-forming region, shaping new solar systems. Protoplanetary disks, proplyds, are forming planets right now inside the nebula. The trapezium cluster's massive stars influence the nebula structure. Organic molecules in the nebula suggest the building blocks of life may be common in space. Mysterious dark regions contain unknown cosmic structures, possibly hiding failed stars or black holes. With each new generation of telescopes and instruments, we uncover more about the Orion Nebula's complex and ever-changing nature. But despite centuries of study, this celestial nursery continues to surprise astronomers. What cutting-edge discoveries have been made in recent years? And what new questions have emerged? KeyCap won the role of modern telescopes, a new vision of the nebula. Hubble Space Telescope, 1990 present, provided the most detailed optical images of the nebula, revealing its chaotic gas formations, proplyds, and young stars. Captured the dynamically evolving interactions between newborn stars and surrounding gas. Spitzer Space Telescope, 2003 to 2020, used infrared light to penetrate thick dust clouds, uncovering hidden stars and protoplanetary disks. Confirmed that planetary systems are forming within the nebula right now. James Webb Space Telescope, 2022 present, captured the clearest and most detailed images of the Orion Nebula ever seen. Discovered new brown dwarfs, failed stars, and mysterious elongated structures hidden within the dust. Detected more complex organic molecules than ever before, strengthening the case for the nebula being a source of life's ingredients. Each new telescope offers a fresh perspective on this ancient celestial nursery, revealing structures and processes we never imagined. KeyCap 2 newly discovered phenomena in the Orion Nebula. Small blue diamond, the Orion Fingers, violent stellar outflows. The Orion Fingers are massive, high-speed jets of gas launched from newly forming stars. These jets travel at hundreds of kilometers per second, shaping the surrounding nebula. Scientists believe they are caused by shock waves from young stars' violent bursts of energy. Small blue diamond, the hidden brown dwarfs, failed stars in the nebula. Using the James Webb Space Telescope, astronomers found dozens of brown dwarfs in Orion. These failed stars are too small to sustain nuclear fusion, but they may still have moons and atmospheres. Some may even have conditions suitable for liquid water, making them potential candidates for exotic forms of life. Small blue diamond, the monster waves of ionized gas. Recent studies have detected waves of ionized gas moving across the nebula at supersonic speeds. These waves are likely caused by the radiation pressure of the trapezium cluster's massive stars, reshaping the nebula in real time. These discoveries show us that the Orion Nebula is not a static formation, but a living, breathing stellar nursery. KeyCap 3 is the Orion Nebula, a window into our solar system's past? One of the most exciting realizations in modern astrophysics is that the Orion Nebula closely resembles the environment where our solar system was born. Observations suggest that the Sun may have formed in a similar nebula over 4.6 billion years ago. The presence of proplyds and newborn stars in Orion gives us a real-time look at what our solar system's infancy might have been like. By studying Orion, scientists hope to unravel the mysteries of planetary formation, including heavy checkmark, how common are solar systems like ours? Heavy checkmark, what role do supernovae play in planetary formation? Heavy checkmark, could life's ingredients form in nebulae like Orion? Scene, a time-lapse of the Orion Nebula transforming over millions of years, with emerging planetary systems forming like the early solar system. By studying the Orion Nebula, we are essentially looking back in time, witnessing a process that shaped our own cosmic origins. KeyCap for the challenges of studying the Orion Nebula. Even with today's advanced technology, there are still significant challenges in fully understanding the Orion Nebula. Its extreme brightness makes it difficult to observe its faintest details. Dense dust clouds block visible light, requiring infrared and radio telescopes. Turbulent gas flows and stellar winds create ever-changing conditions, making long-term studies complex. The nebula itself is evolving. What we see today will not be the same in a few million years. Despite these challenges, astronomers continue to push the boundaries, uncovering the nebula's secrets one discovery at a time. Summary of modern research and current discoveries. Heavy checkmark, the James Webb Space Telescope has revolutionized our view of the Orion Nebula, uncovering hidden objects and complex structures. Heavy checkmark, the nebula is home to newly forming solar systems, giving us a glimpse into how planets like Earth may have formed. Heavy checkmark, mysterious high-speed gas jets, brown dwarfs, and supersonic waves are shaping the nebula in ways we never expected. Heavy checkmark, studying Orion helps scientists understand the conditions that led to the formation of our own solar system. Heavy checkmark, the nebula remains a challenging target for observation, but new telescopes and space missions continue to reveal its hidden secrets. What comes next? The future of Orion Nebula research. As technology advances, astronomers are developing new methods to study the Orion Nebula in even greater detail. Future research may include interstellar probes. Missions like the proposed Breakthrough Starshot could send small probes toward the nebula to analyze its gas and dust in situ. Next-generation space telescopes. Future telescopes, such as the Nancy Grace Roman Space Telescope, will provide even higher-resolution views of nebulae. Artificial intelligence in astronomy. Machine learning algorithms are helping scientists analyze vast amounts of nebula data faster than ever before. The Orion Nebula is more than just a beautiful celestial object. It is a window into the past, present, and future of the universe. Even after centuries of study, the Orion Nebula continues to hold secrets. It is a dynamic, ever-changing region, and our exploration of it is far from over. What mysteries remain? And what new discoveries could the future bring? KeyCap 1, the unanswered questions about the Orion Nebula. Even with the Hubble, Spitzer, and James Webb Space Telescopes, there are many aspects of the Orion Nebula that remain unexplained. What triggers star formation at such an intense rate? While we understand the general process, the specific mechanisms behind Orion's rapid stellar birth rates are still unclear. Are there hidden planetary systems developing inside? The nebula contains hundreds of protoplanetary disks, but their long-term evolution is still a mystery. What unknown structures lie within its dark regions? Recent infrared studies suggest the presence of massive, hidden objects, possibly brown dwarfs or rogue planets. Could the Orion Nebula contain signs of life's chemical precursors? Some molecules discovered in Orion are similar to those found in early Earth's atmosphere. But could they lead to life? As we refine our telescopes and exploration methods, we may one day answer these questions and more. Keycap to the next era of Orion Nebula exploration. The next few decades will bring even more powerful tools to study the Orion Nebula. Small Blue Diamond, the Nancy Grace Roman Space Telescope, 2027, will survey larger areas of space in high resolution, capturing new hidden features of Orion. Small Blue Diamond Future AI-enhanced telescopes. Machine learning algorithms will help analyze vast amounts of nebula data, identifying patterns too complex for human observation. Small Blue Diamond interstellar missions to nebulae, far future. Future interstellar probes may one day venture into Orion, giving us direct measurements of its star-forming regions. The Orion Nebula is a living cosmic laboratory, and as our technology advances, we will unlock even more of its secrets. Keycap 3: What the Orion Nebula teaches us about the universe. Studying the Orion Nebula gives us insight into far more than just one star-forming region. Heavy check mark. It helps us understand how our own solar system may have formed billions of years ago. Heavy check mark. It provides a template for studying exoplanet formation across the galaxy. Heavy check mark. It reveals how stars shape and interact with their environments, influencing future generations of celestial bodies. Heavy check mark. It raises new questions about the role of nebulae in seeding life-building molecules across the cosmos. The Orion Nebula is a glimpse into the universe's past, a blueprint for the future, and a reminder of how interconnected all celestial objects truly are. Keycap 4: Final thought. The endless mystery of Orion. Even with all our knowledge, the Orion Nebula remains a place of wonder and mystery. It is a beautiful and violent region of space where new stars and planets are born. It is a cosmic time machine offering a view into the distant past of our galaxy. It is a source of inspiration, reminding us that the universe is far greater than we ever imagined. The Orion Nebula is not just a celestial object. It is a testament to the beauty, mystery, and endless possibilities of the universe. What other wonders lie hidden in the vastness of space? Only time will tell.